is a false statement. And so the negation must be a true statement. So how to find your A and B? Actually, when you write down the negation, already give you some hints. How you find the A and B so that your A not equal to B, but your A squared equal to B squared. Then you can look at the positive and negative. And can be any real number. Of course, we give the integer is better. Integer is also real number. So we let A equal to 2, B equal to negative 2. And so we have A, okay, 2 squared equal to negative 2 squared. But 2 not equal to negative 2. Okay, so you see you are presenting your negation. Find A, find B, such that A squared equal to B squared and A not equal to B. Then you don't go and write down 4 equal to negative 4, no more this line. Because it's very obvious 2 power 2 is 4. Negative 2 power 2 is also 4. If let's say it's not obvious to you, then you just do more work here. If this is not obvious for you, okay, then you just do some extra works. Then A squared equal to 4. B squared equal to negative 2 power 2, which is equal to 4. So 4 not equal to negative, 4 equal to 4. Or you can just say, so A squared equal to B squared, also can. Either one. As long as you show that A squared equal to B squared, but A not equal to B.
转久会有。
So how you present this answer here is not necessarily always need to write down 4 equal to 4. Or not necessarily always need to write down negative 2 power 2 equal to negative 2 power 2. Just as long as your justification is correct. Okay? Because I got students comment me what the working here always not the same. Of course not same, how come can be same? Then we become memorizing already.
你会死掉。
Okay?
没有。
Finish copying? Okay, for all real numbers, A and B. For all real numbers, A and B.
哇，那下去会死掉了，怎么办？
If A is greater than B, then A squared is greater than B squared.
难转。
So this is a false statement, and so the negation is a true statement. So the negation becomes as if real number A and B such that P and not Q. So A is greater than P, and A squared is not greater than B squared. That means your A squared is less than or equal to B squared. Okay? So give the example. So now, because A is greater than B, A squared is less than B squared. So you can look at the positive and negative also. So you can let your A be negative 1, okay, and your B be negative 3.
没有啊，就打死好不好？
So we have, and then what is your A squared? If you can't see this clear, then you just write down your A squared is 1, and your B squared is 9.
随便弄出来就挖洞。
对啊，这个能快。
Your negative 1 is greater than negative 3, but
哇，什么技也没有，长笨，死掉。哈哈哈哈哈。还没有按住好像。
If you don't want to put down the equal, it's also can because one of course is less than none. Okay?
我转了，我好手长。我帮我转，我 space 少。哎呀，帮我抄一下。你抄吗？你抄一下记了吗？6。怎么办？我死了，我死了。
你有龙客，你有好像开一个。
For this case, if you want to write 1 slash not greater than 9 is okay. But if the question asks you to write the negation of contrapositive, you must change it to less than equal. Okay? So you also can write 1 is not greater than 9. For this case, it's okay. But for the contrapositive conversion, also the negation, you must write down the answer like this. You don't write down the answers like this.
Oh shit.
Okay, question 3. For all real numbers n, if n is even, then n plus 2 over 2 is even. So the negation is exist real number n such that n is even and n plus 2 over 2 is not even. So it's not even is false. So this is false and this is true. So you need to find your n here. So from this negation, you see your n must be even. Even can be 2, 4, 6 and so on. If let's say you choose your n be 2, 2 plus 2 over 2 will be even already. So you must choose your n be 4, 8, 12. So n plus 2 over 2 will become odd. So let n be 4. And so n is even. But you have n plus 2 over 2 is 4 plus 2 over 2, which is equal to 3 is odd. So it's your negation.
这才是重点吧。
第2关我这样找。
这个。
来后面你后面你要记。
后面存的。少一按住，没有按住，没有按住。What？
完蛋了！你现在记，现在。
没有按住啊，别走。
你那打死。
先杀死小丑。对，我这样想。
If 2n plus n is even, then m and n are both even. So this is a false statement, and so the negation is a true statement. So the negation exists integers n and n such that 2n plus n is even and n is even and n is even. The negation, we use the De Morgan law. So you have n is odd or n is odd. Now you try to look at this statement here. So this is a true statement. Okay, if let's say you choose, okay, you say your 2n plus n must be even. And you know that your 2n must be, your 2n is always even from the definitions of even number, right? So to have 2n plus n is even, your n must be what? Huh? Your n must be what?
1.
Huh?
1.
Okay? 2n plus n must be even. This is already even. So your n must be what? Your n must be even. So you let your n must be even. So your n is 2. But you look at this one here. Your n is even. This one must be true. Your n is even. That means this one is already false. Right? So to have this one to be true, this is false. That means this one must be true. So your n must be odd. So you see, why so tough to write down the negation? And give you some hints how to write down, how to find the counterexample here. So you can see 2n plus n is equal to 2 times 1 plus 2 equal to 4. this is even, okay, and n is
喂，我新猪八号。
because either one is true, this one will be true. So you just need to write down your n is not. Okay? Any questions? Any questions?
我要死掉了！西外大大这样打，我要死掉了！
No questions. No questions, then we look at the proving universal statement. So the first method we have here is called method of direct proof. Method of direct proof, we have two methods here.
Yeah.
First method is called method of assertion. So what is method of assertion? Actually, we already see this method of assertion in chapter 2. I'm not sure if you remember this or not. Method of assertion means what?
会转按字给我。
You need to substitute every x from the domain and check that the predicate is true. You need to check for every x
还不转
from
按
the
字给我，
domain.
想打。
So the statement of this form, you see, for the universal statement, you always can change it to the universal conditional statement. Okay, that's why we just consider for this form. So this one can be proved by method of assertion when your d is finite. Because method of assertion, you need to check for every x. So your d must
开组合技
be
还是
finite.
开？
So for example,
我觉得
here,
开
use
一
the
个
method of
用
assertion
开组合
to
技来
prove
死
the
掉了。
following statement. For all n in the set of integer, if n is even and your n is greater than or equal to 4 and less than or equal to 20, that means you have this hypothesis. And this hypothesis you can change it to your
不用不用开。
domain also. Use the change of domain. So now your domain is only from 4 to 20 and even number. So you need to check for all these numbers here. Your n can be written as the sum of two prime numbers. So start from n equal to 4. 4 can be written as 2 plus 2.
我这人贪心，我测你两边升华，我贪心。
10, 12, 14, 16, 18, 20. So check for every n from the domain here.
不有
Okay,
强
you
哦
have this condition. Check for every n and show that the premise is true. So this is called method of assertion. So another example here. For all n from the set of positive integers, again, n is even and n is less than 26. That means your n is start from 2, 4 to 24. Okay? Then your n can be written as a sum of less than 3 perfect square. Should be less than 4 perfect square. Change the questions here. Less than 4 perfect square. Okay, so you can see your 2 can be written as what is perfect square before we go to
讲到很奇妙啫。
what is the perfect square?
来，
We look at the note after these questions here. An integer n is called a perfect square if and only if you can write your n as some other integer